You know that feeling when you're programming and you realize you're just typing the same exact code over and over and over again? Well, what if you could teach the compiler new tricks? What if your code could actually write itself? Today, we're going to dive into one of Rust's most powerful and maybe a little magical features, macros. This is how developers can literally extend the language itself.
Okay, so here's the game plan. We're going to start with a problem that I think every single programmer absolutely hates, boilerplate. Then we'll look at Rust's really clever solution, we'll compare its two different kinds of magic, understand the incredible performance promise they make, and then finally, we'll talk about the hidden price you pay for all this power.
All right, let's kick things off with the problem, that frustrating, tedious, and honestly super error-prone task of writing what we call boilerplate code. I mean, we've all been there, right? You've got this simple, beautiful idea in your head, a clear concept, but to get it into code, you have to write dozens and dozens of lines of just repetitive ceremony. So why is that?
This slide just shows the gap so perfectly. On the right, you have the idea. It's simple, right? A pet with a name and an owner. That's it. But then look at the reality on the left, using a language like Java. Oh my goodness, you've got constructors, getters, setters. All this stuff is just boilerplate. The only truly unique information in that entire block of code is the class name and those two little fields.
So here's the crucial point. Boilerplate exists because languages have a fixed, inflexible grammar. The language itself forces you to spell out every single detail of a common pattern because it has no built-in way to understand the pattern you're trying to create. You're just stuck doing the ceremony by hand. But what if we could teach the language new patterns? What if we could break free? Well, this brings us to Rust's brilliant solution, the powerful idea of metaprogramming. Metaprogramming is a total game changer, seriously. Instead of just writing code that runs, you're now writing code that writes other code. And this all happens during compilation, before your program even starts. It lets you automate away all of that awful boilerplate we just saw. Now, to be clear, macros aren't a brand new idea, but older languages like C use this simple and frankly really dangerous text replacement system. It was like a blind find and replace that led to all sorts of confusing, subtle bugs. The Rust way is fundamentally safer. Rust's macros operate on a structured representation of your code, what's called an abstract syntax tree. They get the grammar, they understand the structure, and that prevents a whole class of really common errors. So Rust actually gives us two different macro systems, and they each have their own strengths. To really get a handle on them, let's use a little analogy. Think of the meticulous Scribe versus the all-powerful Sorcerer. And this table just lays out the difference perfectly. On one side, you've got declarative macros. That's our Scribe. They use a pretty simple pattern matching system that's absolutely perfect for getting rid of boilerplate. On the other side, you have procedural macros. That's the Sorcerer. These are actual Rust functions that can perform incredibly complex transformations on your code structure. Way more powerful for sure, but also a bit more complex to write.
Let's start with the Scribe. It's a bit easier to get our heads around. We'll see how it works by looking at a really simple declarative macro, our own custom version of the common vec macro. The whole process is just wonderfully logical. First, the programmer calls the macro, right? myvec123. Then, in step 2, the macro's definition matches the pattern it sees. In this case, it's looking for a comma-separated list of expressions. Finally, in step 3, it uses those captured expressions to expand into real, valid Rust code. It's literally writing the boilerplate for you. All right, now for the Sorcerer, our procedural macro. It has 3 main spells. The one you'll see everywhere are derive macros. They automatically add functionality to your data structures, like making them serializable. But they can also create totally new attributes or even act like superpowered declarative macros. So why does any of this matter? I mean, this is all cool, but what's the point? Well, it connects directly to one of Rust's most important philosophies, the zero-cost promise. It's all about getting high-level convenience without sacrificing that low-level speed. So a zero-cost abstraction is basically a feature that gives you a much cleaner, more expressive way to write your code, but it compiles down to the exact same super-fast machine code you would have written if you'd done it the hard, manual way. You pay no performance penalty for the convenience.
This quote just perfectly captures the idea. The code that the abstraction generates is guaranteed to be just as efficient as if a careful expert had implemented it by hand. You really get the best of both worlds, developer productivity and raw machine performance.
And this is why macros are the ultimate example of this whole principle. They do all their heavy lifting during compilation. By the time your program is actually built, the macro is gone. It has completely vanished, leaving behind nothing but the perfectly efficient code generated for you. There is absolutely zero runtime overhead. None.
But you knew there had to be a catch, right? Nothing is ever truly free. While macros cost you nothing when your program is running, they come with a very real cost that you pay up front, and we call this the compile time tax.
This chart just makes the trade-off crystal clear. Rust, as a language, deliberately chooses to sacrifice compilation speed to achieve the absolute maximum runtime performance. All that magic of analyzing and generating code, it has to happen somewhere, and it happens during the build process.
So what this means in practice is that the compiler has to do a ton of extra work. It has to compile the macro code itself, then it has to run that macro code to generate your new code, and then it has to compile all of the newly generated code. This can lead to noticeably longer build times, and it's a pretty well-known pain point for projects that use macros heavily. And that leaves us with this final, really fundamental question that gets right to the heart of Rust's entire design philosophy. It's a strategic trade-off, right? You're giving up a little bit of convenience during development in exchange for safety, expressiveness, and totally uncompromising performance in the final product. And for many, that's a price well worth paying.